we're going to look at product to sum and sum to product. So, first one, rewrite the expression as a sum or a difference. So, okay, this looks like a sine of A times cosine of B, where A is 3x, B is 2x. So I'm looking here. So I'm just going to rewrite that formula. So 1/2 sine of A plus B plus sine of A minus B. Right? Now I'm going to substitute in. So A is 3x, B is 2x. So 1/2 times sine of 5x plus sine of x. And I can distribute that 1/2 if I want to, or I can leave it. But 1/2 sine of 5x plus 1/2 sine of x. And that is it. Alright. Let's take another one. This one's a sine. It's going to be here. So A is 4 theta. B is 7 theta. So I'm going to write the formula. So 1/2 cosine of A minus B minus cosine of A plus B. So let's fill in what we have. So 4 theta minus 7 theta and 4 theta plus 7 theta. And let's see what we can combine here. So 1/2 cosine of negative 3 theta minus cosine of 11 theta. Now, this from a couple of days ago. Cosine of negative theta is actually just the same thing as cosine of theta. So I can say that that's 1/2 cosine of just 3 theta. And if I want to distribute the 1/2, I can. So 1/2 cosine 3 theta minus 1/2 cosine 11 theta. That's the final answer. Okay. This next one, I have a cosine. So that's this right here. So let's see. A is just alpha, B is 5 alpha. I'm going to erase this out of my way. I'm going to write the formula. 1/2 cosine A minus B plus cosine A plus B. Alright, 1/2. Substitute some stuff in. A minus B. And then we have A plus, A plus B. And the only thing I also have here is pulling out that negative 14 as a constant. Okay, and we'll deal with that all at the end. So let's see if we can simplify. So cosine of negative 4 alpha plus cosine of 6 alpha. And then I have this negative 14 times 1/2, so that's just negative 7. That's negative 7 times everything, so I can distribute that. So negative 7, and then remember, cosine of a negative angle is the same as if it were positive. So cosine 4 alpha minus, because I'm distributing that negative 7 cosine of 6 alpha. And there we have that. All right. Now we want to find the exact values. So we actually have some stuff we can use on the unit circle here. So this is a cosine times sine. So I'm going to write the formula. So that's 1/2 sine of A plus B minus sine of A minus B. A is 190. Whoa. Not sure what happened there. 95. B is 135. So let's see what we can do here. 1/2 sine of 195 plus 135 minus sine of 195 minus 135. So let's see. What's 195? 195 plus 135. That gets me 330. And then 195 minus gives me 60. So now I will just use the unit circle. So sine of 330 is negative 1/2. Sine of 60 is root 3 over 2. So let's do everybody's favorite and combine that into one fraction. So 1/2 times, let's see, they both have a denominator of 2. So negative 1 minus root 3. And then when I multiply it by 2, or multiply by 1/2, sorry, multiplying across the top gives me just negative 1 minus root 3. And then multiplying across the bottom gives me 4. So there's my answer. Okay. All right, negative 8, and then cosine. So let's, A equals pi over 4, B equals pi over 12, and because we might be adding and subtracting these things, I'm going to make this have a denominator of 12. So 3 pi over 12. That way when we add and subtract, it'll work out nice. Negative 8 is a constant. I can have it out at the beginning. Cosine. I'm going to write the formula. We get 1/2 cosine of A minus B plus cosine of A plus B. And now I will just substitute in values. So A minus B. So 3 pi over 12 minus pi over 12 gives me 2 pi over 12, which I'll reduce in a minute. And then cosine of A plus B would give me 4 pi over 12. Now both of these can be reduced. So 2 over 12 can be reduced to 1/6. 4 over 12, I can divide them both by 4 and get 1/3. Which I really don't need the 1 there. All right, I can combine these. Negative 8 times 1/2 is a negative 4. And now I can get these. Let's see. Cosine of pi over 6 is root 3 over 2. And cosine of pi over 3 is 1/2. So I can combine that into one fraction. Root 3 plus 1 over 2. And then I can multiply by negative 4, but I can reduce this right here. It's going to give me just negative 2. So negative 2 root 3 plus 1. And then you can argue if you want to distribute that or not. So negative 2 root 3 minus 2. Either one is fine. All right. Now let's go the other way. So sum to product. So I have a cosine plus a cosine. So I'm going to use this formula. So A is 8x, B is 2x. My formula, and I'll write it and fill it in as I go. So 2 cosine A plus B, so 10x over 2, times cosine of A minus B over 2, and we'll reduce even further. So that's 5x and 3x. And that's it. All right, I have a sine minus sine. So it's this formula here. A is 3 beta, B is 6 beta, and I'll plug it in as I go. So 2 cosine of A plus B, so 9 beta over 2, sine of A minus, so 3 minus 6 is negative 3 beta over 2. Now here, when we have sine a negative theta, that's the same thing as negative sine theta. So I'm going to take a negative out here. I'm just going to put it at the beginning. So negative 2 cosine of 9 beta over 2 times sine of 3 beta over 2. And we can leave it just like that. Now, in this first one, I didn't put parentheses around it. You can, or you don't have to. All right, let's look at this one. A cosine plus a cosine. I have, let's see, A. Actually, you know what? I think we can do a little bit of algebra first here. Let's factor out a negative 10. I'm left with cosine of 3 theta minus cosine of 5 theta. And now we'll do a cosine minus cosine, where A is 3 theta and B is 5 theta, holding that negative 10 on the outside. So let's do the cosine minus cosine one. So that is negative 2 sine A plus B, so 8 theta over 2 times sine of A minus, so 3 minus 5, so negative 2 theta over 2. And then let's clean this up. The constants I can multiply, so I get 20. And that's sine of 4 theta times sine of negative theta. And remember that negative can be pulled out to the front. So really it's negative 20 sine of 4 theta sine of theta. Okay. Now let's look at exact values. So this is a sine plus sine, where A is 345, B is 75, and let's fill in the formula. So I have that 3 halves out here, so I'm going to have it out here too. So I get 2 sine of A plus B over 2, so 345 plus 75. And then cosine of A minus B over 2, so 345 minus 75, so 270. All right, let's clean this up a little bit here. 420 divided by 2 is 210, and 270 divided by 2 is 135. So now I can combine these. The 2 and 2 will cancel out, so I'm left with 3. let's see, sine of 210 is -1/2, and cosine of 135 is -√2/2. So that's 3 times √2/4, which is just 3√2/4. Okay. Gonna erase it to do the next one. All right, we have a cosine minus cosine, which will give me, let's see, A is 11 pi over 12, B is 5 pi over 12, and I'll just substitute right into the formula. So -2 sine of A plus B over 2, so 11 plus 5 is 16 pi over 12 divided by 2, times sine of A minus B over 2, so 11 minus 5 would be 6 pi over 12 over 2. So let's see what we get. Do some side work. 16 pi over 12 divided by 2 is the same thing as multiplying by 1/2. You guys like to just multiply across and then reduce. 16 over 24, if I divide both by 8, I get 2/3. So that's 2 pi over 3. And then we'll do the same thing here. So 6 pi over 12 divided by 2 is the same thing as multiplying by 1/2. So that gets 6 pi over 24, and I can divide both by 6 and get pi over 4. All right. So let's see, sine of 2 pi over 3 from the unit circle is √3 over 2 times sine of pi over 4, which is √2 over 2. So let's see, that gives us -2 times √6 over 4, which will reduce to -√6 over 2. Okay. Let's look at one more section here. Power reducing identities. Okay. So let's see what we could rewrite these as. Rewrite each expression in terms with no power greater than 1. Okay. So tangent cubed of x. I only have a sine squared, cosine squared, and tangent squared. So I could say that that is really tangent squared x times tangent x. Well, tangent squared, we just want to throw in here. So 1 minus cosine 2 theta over 1 plus cosine 2 theta times tangent x, which we can just change our thetas to be x's because that's just a variable and we are in x as our variable. And then we can distribute the tangent if we want. Honestly, I feel like that's just as good, but tangent x minus cosine 2x tangent x all over 1 plus cosine 2x. Okay. Cosine, could rewrite that as cosine squared theta times cosine squared theta. And what is the formula? We got 1 plus cosine 2 theta over 2 times 1 plus cosine 2 theta over 2. okay? Let's combine it down into one fraction. So the denominator's 4. And now I have to FOIL this out. So that's 1 plus cosine 2 theta. And then that is cosine 2 theta plus cosine squared 2 theta. Okay, I can simplify further. 1 plus 2 cosine 2 theta. And looky here, I can rewrite that as 1 plus cosine of 4 theta over 2, and then we're still over 4. To get rid of this fraction, instead of trying to get a common denominator of 2, I can multiply everything by 2. Okay, so I get 2 plus 4 cosine 2 theta plus 1 plus cosine 4 theta all over 8. And I can combine some like terms here. So just the 2 plus 1. So 3 plus 4 cosine 2 theta plus cosine 4 theta all over 8. And I could split it up if I wanted to. So 3/8 plus 4/8 is just 1/2. So 2 cosine 2 theta over 2 plus 1/8, which I don't need the 1, cosine of 4 theta. But doesn't matter. Both those mean the same thing. Okay. All right, tangent squared is 1 minus cosine 2 theta over 1 plus cosine 2 theta. Sine squared is 1 minus cosine 2 theta over 2. And then I can just write it again. 1 minus cosine 2 theta. Oh, have all of these been an x and I've just been, nope, that was a theta. Okay. Just because the original problem is in x, I will use x. And as I've done this, I think this still should work out. All right. So, I wonder, what's easiest? Okay, so what I'm going to do is, that's one term, that's one term. Both of them have this. So I'm going to factor it out. And I'm left with 1 minus cosine 2x over 1 plus cosine 2x plus 1. Well, I want to combine this into one fraction. So instead of having 1, I'm going to make the common denominator the fraction, because that is equal to 1. And now I can combine the numerators. So I'm going to leave this on 1 minus cosine 2x over 2. My common denominator is now 1 plus cosine 2x. 1 plus 1, and then I have negative cosine 2x plus cosine 2x, and 1 plus 1 is 2. Negative cosine 2x plus cosine 2x is just 0. And now when I multiply these, I have a 2 on the top and a 2 on the bottom. So I'm just left with 1 minus cosine 2x over 1 plus cosine 2x. Ta-da! All right, last one. I can rewrite that as cosine squared alpha times sine squared alpha times sine alpha. Cosine squared is 1 plus cosine 2 alpha over 2. Sine squared alpha is 1 minus cosine 2 alpha over 2. And then I have just sine alpha. Oh gosh. All right, if I combine these into one fraction, my denominator is 4. And now I'm going to multiply the numerators. So you have to FOIL it out. So 1 times 1 is 1. 1 times negative cosine is just negative cosine 2 theta. And then I have plus cosine 2, and I said theta and I meant alpha. And then minus cosine squared of 2 alpha. So if I were to simplify that, I get 1 minus cosine squared 2 alpha over 4 times sine alpha. Well, hey, I need to fix that cosine squared 2 alpha. So really, that is 1 minus 1 plus cosine of 4 alpha over 2, all divided by 4, still times sine alpha. Let me do some scratch work to fix that. Instead of 1, what if I make it 2 over 2? And then minus 1 plus cosine 4 alpha over 2. So when I combine like terms here, I get denominator of 2, and then I get 2 minus 1, which is 1, and then I have to distribute that negative, so minus cosine of 4 alpha. But then that's still all over 4. Well, dividing by 4 is the same thing as multiplying by 1/4. So I get 1 minus cosine 4 alpha over 8, and I still have this I need, times sine alpha. And I think that that is fine. because I could distribute it and make it look nicer. Okay, I'll do it just so you can see it. So really sine alpha minus sine alpha cosine 4 alpha all over 8. So okay, that looks nicer. And then we can really split it if we want to, and I don't, so that's good enough. Alrighty, there we have it.